Right, so what is next for NASA's Mars InSight lander? We announced last week that the lander will head into retirement in just a couple months as the solar power winds down. But until then, InSight is still hunting marsquakes, one of its main goals since landing on the red planet in 2018. And I'm Raquel Villanueva here at NASA's Jet Propulsion Laboratory. We are going to give you a behind-the-scenes look at a really unique place on lab, which is this Mars testing area. And we'll also be answering some of your questions about the InSight lander. Now, we're coming to you live from the In-Situ Instrument Laboratory. It's a space designed like the surface of Mars, so engineers can conduct tests under similar conditions. And behind us, that is ForeSight. It is InSight's Earth twin used for testing. The model is an exact duplicate of InSight, minus a few things that have been removed, like the solar panels, but it gets the name ForeSight because engineers practice doing everything the lander will do on Mars here first. And we are joined by two members of the InSight team, testbed lead Pranay Mishra and project scientist Mark Panning. They'll be answering some of your questions about InSight, what they've learned since it landed on Mars in 2018, and what the future of the mission looks like now that we know the power will likely run out in the next couple months. We want people to get familiar with the InSight lander, so could you give people a quick recap of the mission?
Sure, and it's fortunately it's much easier to fix things on Earth than on Mars. Basically, as I was starting to say earlier, InSight's really the first mission that's been designed to look inside of Mars. We've had lots of missions that have looked at the surface and the atmosphere, but InSight's really designed to see what's happening in the deep interior all the way down to its core. And the main tool we use for that is looking at marsquakes, which are recorded with a seismometer. If you look to the right, this is a model of the seismometer, and we'll talk more about that in a bit. But that's actually what's used to measure marsquakes. And we've measured over 1,300 of them through the mission, and we've used those to look at the interior. We also have a couple other key instruments that are using other ways of looking inside, either by attempting to measure heat flow or by using radio science to measure really small wobbles of the planet.
Great, thank you, Mark. And if you're just tuning in, again, we are answering some questions about the Mars InSight lander. If you have a question, use the Ask NASA hashtag or drop them in the comments below, and we'll be getting to them in a bit. But now to kind of describe the In-Situ Instrument Laboratory, I'd like to have Pranay come over here and do, we'll explain that little dance you have to do with the instruments before, but can you explain why this type of room is important for Mars missions?
Absolutely. So the activities we complete on Mars with both our landers and our rovers are very complex, and we want to give them the best chance of success. So in a facility like this, with a test bed like this, we actually test all the complex activities that we're going to perform on Mars in here first. We'll write a sequence, we'll test it out here in this facility, we'll see what went right, what went wrong, make some tweaks, and eventually when it goes right in here, we'll send it to Mars so that it executes successfully there.
And I had a question about kind of everything we're stepping on, this gravel. Like, why does this have to be here for the models?
Sure. So what this actually is, if you take a look, most people might think they're just some rocks you find outside, but this is actually crushed, unprocessed garnet. And when you think of garnet, you think of jewelry, but this is the version before it turns into that. So if you actually pick some pieces out and hold them into the light, you can see little glints of red for the jewelry that they could one day become. In here, we use them as our practice deployment surface for InSight.
So you're a tiny rock polisher. You can
That's right, that's right. Just a little bit of jewelry here.
And then also, why are you both clipped into the ForeSight right now?
So ForeSight and most test beds have very sensitive electronics, both to temperature and things like electrostatic discharge. And so to ensure that myself or Mark or anyone who's close to these electronics doesn't cause any accidental electrostatic discharge, we use these things called grounding straps, connect to a ground wire here to ensure that there's no chance that we can endanger these electronics. Same for the AC that was mentioned earlier. These electronics are sensitive to temperature. We don't want it to get too hot in here, otherwise that might damage it. So we have this very loud AC going to ensure that it stays cool in this room.
All right, so if you see them do a little dance, that's why they're keeping the ForeSight safe. And speaking of ForeSight, can you kind of go through some of the parts that we see here?
Sure. So if we start from a far view, what we have here is ForeSight's deck. It's the same size as InSight's deck, and as you mentioned before, we just don't have solar panels on it. One of the most popular items people see in photos is our instrument deployment arm, the IDA. So this arm is what was used to deploy all our deployables onto the surface of Mars. There are 2 cameras on InSight, and so we have 2 cameras here on ForeSight. The first one is the IDC, the instrument deployment camera, and that's that red box attached to the arm. And then we have a second camera. We'll have to swing around a little bit, but we have a second camera. There's a red box to my right. That is our instrument context camera, or ICC. So when you see the fixed landscape images come back from InSight, that's from the ICC. And anytime you see images of the deck or close-ups of the instruments, that's coming from our IDC. Speaking of instruments, Mark had already mentioned the seismometer to my right, which is this orange hexagon here. In our photos, what you typically see is this white dome called the Wind and Thermal Shield, abbreviated to WTS. This is placed on top of the seismometer to ensure we don't have any noise or less noise in our data taken from the seismometer. And here we have a model of the HP3, which is the mole, the penetrator. And so these are the 3 items that we would practice deploying in this test bed.
And what has kind of been some of the most significant and important tests you've done since InSight landed?
The most important test we did was practicing these deployments. Before we landed, we weren't sure what the terrain would look like. We could have a tilt, we could have rocks in our workspace. So in this room, we would add rocks to our field. We would set up boards with different tilts up to 15 degrees. And these items would be up here on the deck, and we would use the robotic arm and practice lifting them and putting them onto the surface. We wanted to make sure we had good accuracy and good precision so that when the scientists told us where they wanted these on the surface, we could get them there.
All right, and speaking of scientists, Mark, I have some questions for you. What have scientists learned from InSight?
Yeah, so as I said, our main mission goals were to look at the interior Mars. In particular, we wanted to know more about its crust, which is the rocky layer on the outside, its mantle, which is the rocky layer below it, and its core, which is the metallic layer in the middle. And by looking at all of those marsquakes we've talked about, so there's over 1,300 of them recorded, we can look at how those waves that we record at InSight go through the inside of Mars and use that to figure out what's happening on the inside of Mars. So we can now tell how thick the crust is. It's not as thick as some models suggested before, but it makes a lot of sense. We can now tell how big the core is. It's actually ended up being on the big end of our expectations, which is actually going to be very interesting moving forward in trying to understand the science of how Mars formed and evolved. If it's big, it's also less dense, and that tells you stuff about the kinds of stuff inside the core. We're also really interested in how active Mars is. All those Marsquakes we recorded, we need to know why they're happening and where they're happening. And some of the most interesting stuff is that many of those quakes happen in an area we call Cerberus Fossae, which geologically speaking is very young in terms of volcanoes. Now when I say geologically young, it's less than 10 million years old. But we know it has steep sides on its features that have rock falls that go down them, and we suspected going into the mission that we would see Marsquakes there. And it turns out we did see Marsquakes there, and also many Marsquakes all around the planet. So there's been a lot of really interesting science to come out and a lot of science to come.
Yeah, speaking of science to come, will you be able to use the data that you have received and continue to receive in the future?
Absolutely. So I like to reference back to the Apollo missions. So they landed seismometers on the moon that operated after the astronauts left, and they kept operating until 1977. But then they got turned off in 1977. But people are still making studies on those quakes today, and there's every reason to think people are still going to be studying Marsquakes from InSight for decades to come. In fact, all the data is publicly available. With a slight delay, but most of the data for the mission you can just download from the sites that seismologists work from, whether you're on the science team or not.
Lots of science years ahead, and I do like the aspect that the public can also access it as well. And we are getting some viewer questions in, so if you're just tuning in, we are asking some questions about InSight, and we'll be answering your questions. Use the hashtag AskNASA or drop them in the comments below. And first off, for Mark, we have Roshana who asks, will there be a future mission that will follow up in the discoveries made by the InSight lander?
The short answer is I don't know. Those decisions are made by NASA, and so I have ideas for some great things we could do. It would be great to have a mission someday that went to Cerberus Fossae and looked at marsquakes. And there are, I am certainly going to be people that are proposing missions to go back to Mars, but we can't predict exactly what's going to happen.
And I have another question coming in from Cynical LED. I think this is going to be for Pranay. What happens if the solar arrays are cleaned off by wind? Will you bring the mission out of retirement?
So I can't speak to the last part of the question about bringing it out of retirement. That's a very broad question if we could be able to do that. But if there was a cleaning event on the solar panels, we would expect to have more power in our batteries, and InSight would be able to operate for a longer amount of time. When that happens and if that happens, unfortunately, is not up to us.
Okay.
I would like to follow up on that real quick.
Right.
So one thing we do know about how the spacecraft is designed is that at some point it won't deliver enough energy to keep the batteries charged up, and we'll stop communicating with it. We expect that to happen sometime this year. But if in the future the solar panels were cleaned off, the spacecraft is designed that it would then start charging up the batteries, and it would start to try to communicate with Earth. And there's a chance that we could hear it again and bring it back. It's possible, it's designed to be able to do that. But once again, that depends on what Mars does. And so we can't predict what's going to happen. But the spacecraft is designed to be able to recover from its battery being drained.
That's a nice, hopeful answer. So we have some people commenting on what they see behind us and how ForeSight is kind of on these blocks. Could you kind of explain why that is?
Sure. So as most people know, InSight is a lander, so it does not have any wheels and it doesn't move. So one of the things we like to test in this room using ForeSight is, besides the deployments, is when the HP3 mole anomaly occurred. We wanted to ensure that we could test every possible solution in the space. What we actually did was we had brought in the flight spare for our mole, brought it to this room here, connected it to ForeSight, and we set up a box in this space to give time and depth for the mole to actually penetrate if we needed to during our testing. So we needed space downward for the mole to penetrate, so we actually had to raise the lander up using these cinder blocks to ensure that the height between the deck, the robotic arm, and the mole in our testing area was the same as on Mars, to ensure that we were actually testing in a flight-like way.
It's fun to see like all these little parts and how they have one specific use in here.
That's right. This is our play sandbox. This is the best part about this job.
And we have some more questions coming in about the science. Again, if you'd like to ask a question about InSight, use the Ask NASA hashtag or drop them in the comments below, and they are patiently doing their dances. They try to make sure that they are connected to the spacecraft. Dan Shields asks, will there be seismic instruments in the upcoming Venus missions?
Upcoming Venus missions. So at this point, the Venus missions that have been selected, none of them are going to the surface. So there wouldn't be any seismic instruments on those. There have been proposals for possible ways of doing seismology on Venus from orbit, but it would be very different than what we're doing on InSight. So there is possibility in the future, but in the currently selected missions, there's no plan for seismology.
And you know, someone was just asking again, what is this? What are these little bracelets that you're wearing?
Sure. So we have a lot of sensitive electronics in our testbed area, and they are sensitive to things like temperature, and the other thing is electrostatic discharge, ESD. So if you ever touch a doorknob, a metal doorknob, and get a little static shock, that's what we're trying to prevent here. We don't want any of those shocks to go into our electronics and cause any damage. What these wrist straps do is they ground ourselves through the spacecraft to our facility ground. So they make sure that if we have any charge, it passes through safely and doesn't actually affect our electronics, and we can't cause any damage. We wear these when we are close to the electronics. If you're a certain distance away, then you don't need to wear one.
Great, and then we have a couple science questions coming in now. Derek Ward asked, what is the core made of, and does the core have a solid core, or is it all liquid?
That's a really good question, and the short answer is we don't know all of those answers yet. But what I will say is that the core is metallic. Its main main constituents are like the Earth, iron and nickel, but its density is low enough that it has other things in it. We don't know exactly what all of the other things are. A lot of it is probably sulfur, but there are other things, carbon, hydrogen, other lighter elements that could be in there to make it be less dense. And we're still trying to work out what all of those could be. In terms of whether it's liquid or solid, we can say with a high level of certainty that at the top of the core, it's liquid. We know that for sure, because the seismic energy we see reflects very strongly, and also the radio science tells us that the motions of the planet are consistent with a liquid core at where the core and the rocky mantle come together. We can't say for certain whether it has a solid inner core like the Earth does. We don't have any evidence to say one way or the other, but I will say under the pressure and temperature conditions of Mars, it's likely that it's all liquid, but we don't know that for sure.
More answers to come. And then War Hero asks, how long was the mission designed to last, and did the mission meet everyone's expectations when it comes to the science that came from it?
Absolutely. So our prime mission was scheduled to last about 1 Mars year, 2 Earth years, approximately. And we designed the solar panels such that we would be sure to have enough energy to get through that, and we did. We had plenty of energy to get through the prime mission. In fact, we got another extended mission that we're in right now that extended it another 2 years. We recorded a whole lot of events. We've answered all of our science goals, and so we actually got to looking at the interior of Mars, and we're actually extremely happy with the amount of science we've been able to achieve, and there's still more happening. I didn't mention it, but we actually had the biggest event of the mission just about a month and a half ago. And there are so many studies that are underway looking at all of the new data we can get with such a big event. And when I say big event, it was magnitude 4.7, which on Earth isn't that big, but on Mars was far bigger than anything else we'd seen.
And I just want you to know that you have a fan watching right now. Your daughter says hi. So you're doing great here. And I would also like to know, why has the seismometer gone on longer than previously planned? More phrasing, I think, is they want to know is, could using the seismometer cause it to accidentally shut down unexpectedly by continuing to use it?
So I will say we had a time period. This is very interesting stuff happened back about late last summer in 2021. We were entering the time of the Mars season called aphelion, when it's farthest from the sun. And at that point, we're farthest from the sun, so we got the lowest amount of solar energy, and we were at our coldest temperatures. And we were very concerned that we weren't going to be able to continue operating instruments through that time. The engineers, including here in the test bed and multiple places, came up with lots of great plans to try to get a little more energy out, and they dumped actual rocks on top of the deck that then blew across the solar panels and cleaned them off a little bit and kept us going for longer than we expected. And that's an amazing thing, and I have all sorts of compliments for the engineers for making that work. But right now, we are no longer running the seismometer continuously. We're running it about half of the time. We are carefully monitoring energy, so it's not at this point going to make the spacecraft stop operating. But at some point, we're going to get to a point where we may not be able to keep doing that. But the engineers are keeping a close eye on all of that.
Yeah, thanks to Pranay.
There's a large operations team that Mark was mentioning that every day models energy, looks at the data that's coming back, plans how to use the instruments so that we have enough power. So there's a huge team behind all the success for InSight.
Yeah, absolutely.
And we were getting some questions kind of just about the room in general. So this has been used like historically, not just for InSight. There's been many other missions, and kind of what you see behind there is from a previous rover mission, and there's all these different parts here. Could you kind of get into that too?
Sure. So one of the first missions tested here are the Spirit and Opportunity rovers. So actually at that time, there was a whole different surface in here. But this building was built to test those 2 rovers. After they had left, Curiosity for some aspects were tested in here. Their test bed was here. Just recently, Perseverance landed on Mars, and so their test bed is actually, they're our neighbor, so we play together in the sandbox area. Going forward, new missions will use this building. So this was created as a test environment and as a universal test environment, so we can reshape it every time we have a new mission that needs space. One of the things you were mentioning behind me, the black and white dots, are a cal target. So for some of our rover missions that were in here, they were testing some of their cameras and doing some calibration. They used that target to test out their cameras.
And you've also mentioned too, these other cameras around here. What are the 4 cameras all around us? Are they for InSight?
Yeah, so we have these 4, and they look a little black and silver cameras going all around the InSight test bed. Those are called Vicon motion capture cameras, so they're commonly used in Hollywood and video game design, and they do precision motion tracking. What we use them for is, after we practice each deployment, we actually put a tracking dot from these cameras on the SICE or the HP3 or the WTS to see where we placed it and did we hit our target. We wanted to practice our accuracy and precision, and so using those cameras, we were able to tell how close we got to our target spot and make tweaks as needed.
Great, and if anyone's watching, they have a great insight on the InSight lander, and so if you have any questions you'd like to ask, use the Ask NASA hashtag or leave your comments in the comment box below and questions as well. So we have a couple other questions coming in. Let's see here. We have some personal questions coming in. What inspired both of you in your careers, and what led you to NASA and JPL?
Sure. So a couple things for me, but one, my cousin is an astrophysicist, and so when I was young, he would talk about the stars, talk about space, show me things through a telescope. And when I would see those things, he would study them behind a telescope, and my first thought was, why don't we go there and look at it? And then that really sparked my interest in space exploration. And since then, I just wanted to be part of an organization, which NASA is, that helps go out into space and create new discoveries. What about you, Mark?
Yeah, I'd say I got involved in this through a series of happy accidents. I don't think at any point in my life I planned on working for NASA. It was never the plan. I ended up in college becoming a geology major because there was a class that let me go hiking in Montana, and then I took more classes. I was good at math, so I started studying seismology, which is geology plus math, more or less. Mm-hmm. For grad school, I focused on the Earth, in order to stay in Berkeley, where I did my studies, I got a project that involved thinking about what seismology would look like on Europa, which is a moon of Jupiter. It was just somebody had a project, and I was like, that sounds like fun. And since then, I've just been following opportunities like that, and somewhere along the line, the lead of the mission, principal investigator Bruce Bannert, talked to me and said, we're thinking about doing seismology on Mars. Would you like to be involved? And I said yes with a big smile on my face. And now, 14, 15 years later, I'm still working on that project.
That's great. And we have some questions coming in for you, Mark, which we'll get to in a second. But a lot of people are curious about the panels, the solar panels. Can they be cleaned off on Mars?
So InSight itself does not have the capability of cleaning its solar panels. If they do get cleaned, it would be hopefully through one of the wind cleaning events that Mark's mentioned. One of the questions that does get asked is, why don't we have a way to clean our solar panels? So the goal of InSight is to collect the science data and answer the science questions that Mark's discussed, which we've done extremely well. Anytime you want to add more engineering complexity, such as a way to clean solar panels, we've incurred now, we'll have new actuators, new mechanisms, we'll have to have a way to test it, we'll have to have a way to make sure that it works, we have to have a way to ensure that those items can't actually harm any of our science collection. So our first priority is to ensure that anything we do will answer the science questions and make sure we bring our science data back. And as Mark mentioned, the solar panels were sized so that they could meet the prime mission without requiring any cleaning.
And we're going to head back to the science questions. We'll do our little dance with with their
become
bracelets.
internally
I know.
entwined at this point.
It's fun to see. So, few science questions coming in here. Has the lander moved during weather, storms, or quakes?
On the scale of what people would think about as moving, the answer is no. It's been very stable. People hear about big windstorms on Mars, and they do have very high velocities, but the atmosphere is very, very thin on Mars. It's about 0.5% as dense as our atmosphere, and so even when you have very strong winds, it actually doesn't have that much force. If you've seen The Martian, the beginning scene wouldn't happen on Mars. You wouldn't have enough energy to knock antennas over and do all of those things. So hasn't moved on a large scale, but it does move on the very small scales that the seismometer can measure. As a matter of fact, before we put ourselves down on the surface, we were able to turn on one of the seismometers while it was still on the deck. And we measured how much the lander moved in the wind, and it actually moved in a measurable way back and forth, very similar to how the Viking landers moved, which had seismometers on them, but never got deployed down to the surface. So they never saw marsquakes, they just saw how the lander moved. So that's all about how sensitive the seismometer is. It can measure motions that are about the size of a hydrogen atom. So very small motions can be seen, but not to the point that you'd actually physically see the lander moving.
Yeah, that's quite the visual, though, to picture an atom moving. And the next question is about temperature. How hot are the temperatures during the day on Mars, and how cold does it get at night?
I don't want to answer that incorrectly.
Okay.
It does get very cold. I will say that we, in the warm electronics box on the inside of InSight, which is inside there where you can't see it, over time we've let it get colder than we initially designed for, but now it gets down to temperatures of minus 35 Celsius, minus 38 Celsius. The surface gets much colder than that, but I don't know the exact number, so I don't want to say an incorrect number. But
No.
it does get quite chilly, and during the day, it still is generally below 0 degrees Celsius. So even on the balmiest summer days, it's still very cold on Mars.
No problem. We can get you an answer in Celsius and degrees at a later time, but thanks. That was a great question. And then question for both of you from Sin City Jim. He says, I know they're just machines, but I get kind of sad when they come to an end. It's almost like the death of a good friend. Do either of you feel that way when you think of a mission coming to an end? I don't know who'd like to go first.
I absolutely feel that way. InSight was the first flight project I got to work on when I joined JPL. I've been on it now for 5.5 years. I feel like InSight's my friend. I feel like every time InSight makes a discovery or something amazing happens with InSight, I get excited, the whole team gets excited. Whenever the mission does end, I will be extremely sad, but feel very fortunate and lucky to have worked on it.
Yeah, as I said in an answer to an earlier question, I think I've been working on InSight for around 15 years now. So this is a big part of my life. It's been obviously something I'll always think about. We had an earlier video where I showed my arm. I don't know if I could do that here, but there you go. There's the InSight logo. I will say that InSight's left a permanent mark on me. And obviously when it ends, it will be very sad, but all things must pass, as George Harrison would say, I guess.
I think a nice way to conclude it is, what is your favorite memory of InSight?
That is a tough question to answer. There's been a lot of good memories. I think for me, I spent most of my time working on InSight in this room. And as I mentioned, we practiced all our deployments in here. So I think really every time we got the seismometer to touch down, we got the WTS, the wind and thermal shield on top of the seismometer, and we got the HP3 down. Each time those three events happened, I felt elated. It was just amazing that the things we tested in here so precisely, we were able to do on Mars successfully.
Yeah, there's a million, and so I have a hard, I'll say probably the most overall intense experience. So I started at JPL in 2017, just the year before we actually landed. And then once we actually landed, for the next 2.5 months while we were doing the deployment process, it was all the time InSight. We had meetings constantly, and we were just talking through everything, and it was just a very intense experience. In fact, for the first week, we were on Mars time, and I had to come in the middle of the night, that was, yeah, that was like nothing else, I guess.
What is Mars time for people who might not know what that is?
So basically, the Mars day is a little bit longer than the Earth day, and when you're working and you're trying to do things on a quick pace, you want to line up your work schedule to when we can communicate with the lander. And so that timing depends on time of day on Mars, not time of day on Earth. And so for the first week or so, we timed our working shifts to be matching up with the uplink and downlink times on Mars. And that would shift a little bit each day, about 40 minutes. And it happened to be at that time of year, it was kind of in the middle of the night. So I got to see JPL in the middle of the night. And there are crazy raccoons on lab in the middle of the night.
I don't think people know about all the critters that kind of live around here. Is there anything you'd like to say to your fellow team members as well?
I just, I really want to emphasize that this is a huge team effort. There are hundreds of people that have been involved in this, and I cannot list them all. We have hundreds of people on the science team that I'm dealing with directly. We have hundreds of people on the operations team. We have all of the people working here at the test bed, and all of them were essential to make this happen. There's no way we could do this without everybody working together, and so everything that happens is just such a team effort, and it's hard to imagine how much it depends on all of these different people.
Yeah, I want to just echo Mark's comments. There's a massive team of engineers, scientists, and others who made InSight successful, and I think the greatest joy we all have is we all got to work together on this amazing mission and got to do something novel with the work we did.
Yeah, and it was nice to see, you mentioned before, visions come to life with the instruments and put it all together. Well, that is all the time we have today. Thank you for your questions, and thanks to Pranay and Mark for answering them. And if you want to learn more about InSight, visit mars.nasa.gov/InSight and follow NASA InSight at NASA InSight on Facebook and Twitter. Thanks for joining us.